Welcome to this Linux lab exercise on restricting user session timeouts. In this hands-on lab, you will learn how to automatically log out idle sessions, an important hardening step for any shared or production Linux system. We will configure the shell timeout using the tmout variable, enforce it for every user, disconnect idle SSH connections, and then verify each setting step by step. Let's begin. Here is what you will learn and what you need. By the end of the lab, you will be able to automatically log out idle shells with tmout, enforce a system-wide read-only timeout, disconnect idle SSH clients, and verify that the policy actually works. For prerequisites, you need a Linux machine or virtual machine, Ubuntu, Debian, or a RHEL family system, plus root or sudo privileges, basic command line skills, and about 15 minutes of time. First, the concept. Bash and Korn shell include a special variable called tmout. Set it to a number of seconds, and an idle interactive shell will log itself out after that time. Try it right now. Type export tmout equals 60 at a prompt, then stop typing. After 1 minute, the shell prints timed out waiting for input and closes the session. This works, but any user can simply unset it. The next tasks make the setting persistent and enforced. Task 1. A per-user timeout. Open the user's bash profile with nano and add the line, export tmout equals 300. That's 5 minutes of inactivity. Save the file, then either log in again or reload it with the source command. Confirm with echo $tmout, it should print 300. This protects one user only, and since they own the file, they could remove the line. So in task 2, we enforce the timeout for everyone. Task 2. Enforce a system-wide read-only timeout. As root, create a new script called session timeout.sh inside etcprofile.d. Put in 3 lines, tmout equals 300, read-only tmout, and export tmout. Scripts in this directory run automatically for every login shell, so all users get the setting, and the read-only keyword means nobody can change or unset it afterwards. The change takes effect at each user's next login. Test it by opening a fresh SH session. Task 3. Disconnect idle SSH sessions at the server. Tmout only guards shells. A user inside another program could stay connected forever. The SSH daemon can close idle connections itself. Edit the SSH server config and set client alive interval to 300 and client alive count max to 0. Then reload the service. systemctl reload SSHD on RHEL systems or systemctl reload SSH on Ubuntu and Debian. Now, any client that sends no data for 5 minutes is disconnected, even if they bypass tmout. Task 4. Verify the policy. Echo $tmout should print 300. Try tmout equals 9999. Bash must refuse, saying read-only variable. Next, run sudo sshd capital T and grep for client alive. You should see client alive interval 300 and client alive count max 0. Finally, do the real test. Log in, walk away for 5 minutes, and confirm the session closes on its own. Repeat with a second user account to prove the policy is system-wide. A few caveats and best practices before you finish. tmout only works in bash and KSH. A different login shell can escape it, and terminal multiplexers like tmux or screen can keep sessions alive. That is why we layer controls, the shell timeout plus the SSH server timeout. Pick a value that balances security with usability. 300 to 900 seconds is typical for servers. For stricter environments, look at PAM and systemd login options. And always document the policy for your users. Let's wrap up with the validation checklist. You should have a per-user tmout of 300 in bash profile, a system-wide read-only tmout script in profile.d, client alive interval and client alive count max set, and the service reloaded, and a successful live idle session test. If every box is ticked, congratulations! You have completed the Linux lab on restricting session timeouts. Thanks for watching, and see you in the next lab.